Hi everyone, I'm Kent Louie, science teacher and talking head, talking about science education and broadcasting from beautiful Vancouver, Canada. This is episode 98. Now, quick question. What do the following Olympic sports have in common? We have boxing, diving, artistic gymnastics, and break dancing. Answer. They're all sports where the outcome is determined by a panel of judges, because these sports have elements that can't be captured through a traditional scoreboard. So for example, in boxing, if a match goes the distance and nobody wins by knockout, the match is determined by the judges' scores. And the judges award points for things like domination of bout, technique, tactical superiority, and not just on punches landed. In things like in sports like diving and gymnastics and breakdancing, there's elements of artistry that need to be assessed. You know, the use of judges doesn't make any of these sports any less of a sport. If we consider how much training and discipline goes into each one of the sports, I think we can all agree that those are legitimate sports. Think about boxing. I think everyone thinks boxing is a sport. And so, if you think about it, in the world of assessment and standards-based grading, we have the same debate. Just because teachers assess student performance of specific skills in standards-based grading using things like rubrics and proficiency scales and not points scored on a test doesn't make SBG any less effective than traditional grading. In fact, standards-based grading and rubrics are meant to assess things that traditional marking doesn't typically address, things like communication, application, analysis, and other science skills. And I think a traditional grading system would struggle with assessing those skills as well. I'll show you what I mean through an example I developed for a test in a second. But before I continue, handouts for this episode are available at realsciencechallenge.com/EP98. And please subscribe to our YouTube channel. Now, here's a question from my most recent test on static electricity. It's a question that's actually based on this electrostatic series. You may have seen this before. This is where students can predict which materials will have a positive static charge and which ones will have a negative static charge after we kind of rub them together. However, on my test question, students are given some fictional data on some fictional materials, and they're asked to develop their own series down below based on that data. So this question is meant to assess a student's ability to apply their knowledge in a different context. So we're going to try to mark student answers, students' responses, using a rubric first and then using a traditional point system. Okay? So on my rubric, proficient means that students were able to show the relative order of materials on that scale. Kind of like this. Okay, this student got proficient. As you can see, relative to each other, they actually did a good job in showing which ones were more likely to be positive and which ones were more likely to be negative. Okay, if a student got proficient, it meant they scored a low A or a high B, or like an 85% in the traditional sense, because they're able to use that data and come up with this. So that's proficient. That's like a high A, or sorry, a low A, high B. Now, if a student were able to get an extending, it meant that the student showed a greater depth of understanding. In this case, check it out, this is extending. They were able to take this data over here, all those numbers, and they're able to show, use the lines below and show kind of quantitatively the gaps between each material, how far along the spectrum they are. You know, this is an additional level of detail. I didn't ask for this. But if the student was able to take this information and embed it into here, that's extending. That's another layer of sophistication. This would be a high A, or 95%. So both proficient and extending are A's. The only difference is one's a low A, one's a high A. Now, if we tried to score this using a traditional point system, how many points would we assign? Well, we could maybe use a 4-point system, similar to like, 4-level rubric. But the problem is that a student who got proficient, remember, this is a proficient answer. a student who scores proficient would get 3 out of 4. That would sound like a 75%, which would be like a low B in our system. And that 3 out of 4 doesn't really show that a student has a complete understanding. It sounds less than a complete understanding. So 3 out of 4 doesn't work. So you're probably thinking, maybe we can assign like more points. Maybe make the question out of 10 as opposed to out of 4. The only problem is if we make it out of 10, now we got to distinguish between a 6 and a 7, and a 7 and 8, and 8 and, well, et cetera, et cetera. This becomes more of a headache to try to distinguish all those levels. So the traditional point system isn't the end all and be all. They are also imperfect, if you think about it, when we're trying to assess skills. Thus, as imperfect as this proficiency scale may be, when we use it in standards-based grading, it does a fairly good job if it is well defined. And the key thing is, we always need to define our rubrics in a detailed and fair way. Detailed so we can distinguish each level clearly, and fair in that our expectations at each level matches what students can do at each grade level. That's it for this episode. Please smash the like or subscribe button or leave a comment below. And Handouts once again are at realsciencechallenge.com/EP98. Thanks for watching. And let's talk science education again soon.